So this is my overview of the practice test about atoms. The first 5 questions are about names of guys. One day I wove a story together, and I just picked these 5 names out to remind you of the story. So the calculus equation generating the quantum numbers, that comes from treating an electron as waves, and so everything that we've learned about in terms of shapes, like that's an s orbital, and this is a p orbital. The d orbital had that double dumbbell shape. So all those orbital shapes are calculated from a wave equation developed by a guy named Schrodinger. So the n, l, m, and s quantum numbers come from that equation. This guy noticed that light emitted from neon and other lights consists of specific wavelengths, and that was the day I did the light demo with the little tube and the glasses. And we said this model of the atom came from that light demo, and that was developed by a guy named Niels Bohr, B-O-H-R. John Dalton is the guy that first developed modern atomic theory. And the electrons, I showed you a cathode ray tube with a magnet about 3 weeks ago. And that was a guy named J.J. Thomson that did that work. Then, of course, we said that if you ever looked at an electron, you would change where it's going because electrons have so little mass that the charge on an electron, the mass of the electron is so small that when light hits it, it changes its path. So that's why we can't treat the electron as a particle. We can only treat it as a wave. I didn't put de Broglie on there. Remember, we calculated the wavelength of a duck and learned that matter can have a wavelength. And the wavelength of normal matter is not important, but the wavelength of an electron is important, it's significant. So I've already alluded to the answer number 6, that chemists describe electrons in atoms as waves, not particles. We get to these next questions, we need a periodic table, so I went and grabbed one. Number of particles you expect to find in nitrogen-14. Well, if it's nitrogen, it's N right there. Or if you need to, you can go to my periodic table on my website. And nitrogen, you see, has 7 protons. So the number of protons in nitrogen-14 would be 7. Now the number of neutrons in nitrogen-14, remember if it's nitrogen-14, it has a 7 here and a 14 there. This number is the protons and neutrons. This is the protons. So there would be 7 neutrons, 14 minus 7. I want to remind you that you could also have something like nitrogen-15. And that would be the protons and neutrons. Notice how they changed. So if the number of neutrons changes, those are called isotopes. So isotopes are atoms of the same element with different numbers of neutrons, because neutrons can change. So changing neutrons makes different isotopes. I'll write this down. Isotopes. And changing electrons makes different ions. Okay, so the atomic mass of nitrogen-14 is 14. That's the mass. Okay, so that would be 14. The answer is 14. It's on the next page. All right, so changing electrons, again, if you change electrons, you're changing the charge, and that means you're changing ions. So let me show you. So if you have nitrogen at 7, and they have 15 right here, and you had a -3 charge, the number of protons, neutrons, and electrons in that guy would be this. So you have protons would be 7. This is for this atom right here. The neutrons would be 8. The electrons would be 10 because that's a -3 charge. And that goes back to the proton, neutron, electron sheet that we did. All right, now moving on to the next page. two atoms of the same element with different numbers of neutrons. We just talked about that. It's isotopes. Two atoms of the same element, different numbers of neutrons, isotopes. If you had phosphorus with a -3 charge, phosphorus normally has 15 protons. So if you have a -3 charge, it's going to be 18 electrons because it's gain 3. So how many electrons would you need to gain in order to have, would nitrogen need to gain in order to have 8 electrons in its outer shell? Remember that everything in this column has 1 electron in its outer shell. That column is 2. So 1, 2, 3, 4, 5, 6, 7, 8, except for helium, which only has 2. All right, so nitrogen has 5 in its outer shell, so it's going to need to gain 3, which is equal to the number of electrons. If it's neutral, the electrons equal the protons. All right, what's the mass number of this guy? You've got 16 protons, 19 neutrons, so that's 35. Electrons are kind of like if you get on a scale before you step in the shower and you get your weight, and then you step in the shower and take a shower and some of your hair falls out, and you get back on scale again, your weight's not going to look any different. That's because the hair is so little in mass compared to the rest of your body that it's irrelevant. And that's the way electrons are relative to the atom. They weigh so little that we don't count them. Okay, an atom, in order to become excited, it can absorb specific quantities of energy. So that's why only certain colors of light made the electron get excited in the little animation and also in the spectroscopy lab that we did. All right, the number of sublevels in the fourth principal energy level. So now we're getting into the diagonal rule and the sublevels and quantum mechanics. So the first energy level was 1 sublevel, second energy level, remember, had an S and a P, and the third energy level had the sunny and the pink, S and P, and a dark. Fourth energy level has 4 sublevels. They are S, P, D, and F. Okay, if an atom containing 16 electrons gained 1, it's going to have a -1 charge. And the highest, and by the way, you could say, well, wait, the atom implies originally it was no charge. Okay, the highest energy sublevel in aluminum. So if you write the configuration for aluminum, aluminum has 13 electrons. So we do 1s2, 2s2, 2p6, 3s2, 3p1. Okay, so the highest energy sublevel would be 3p. And there would be 3 valence electrons, but only one of those is in the highest energy sublevel. Number 19. Which of these does not exist? 1s, 2s, 2p. You don't see a 2d there, do you? So that would be 2d. So the question is not, the answer to that question, 2d or not 2d, that'd be not. Or wait a minute, or was that 2b? Anyway. All right, so the secondary, the L value, tells us the most about sublevels. So remember, you had N, L, M, and S. The number of values of L tells you the number of sublevels. The quantum number that designates the orientation of the orbital in space, that would be the M quantum number. So like if you have, if I drew a picture of an atom, here's the 1s, here's the 2s, then the 2p, you have one that's on the x-axis, one that's on the y-axis, and one that's on the z-axis.
You're still here.
Still here. That's Miss Shelby coming in, watching me make a video. So we have the 3 orbitals here, and the M values can be -1 or 0 or 1, and that designates the orientation of the orbital in space. I'm going to stop the video here and say hi to Ms. Shelby. Now we'll come back. It's getting kind of long anyway.